In this live session, we are going to solve some problems based on the topic similarity from Maths Part 2 Class 10. So those questions are multiple choice questions. That means a question is there and 4 options are there. We have to We have to choose the correct alternative. So let's have the first question. So this is the question regarding the similar triangles. It is given that triangle ABC is similar to triangle DEF. It is given to be similar to triangle DEF. Then AB divided by D is equal to dot dot divided by EF. So instead of this blank space, what would be there? AC, DF, BC, or none of these? That is the question. Now we don't need a diagram to have the answer of this question, because it is given that these two triangles are similar. That is, triangle ABC is similar to triangle DEF. So as these two triangles are similar, we know the property of similar triangles. That is, if two triangles are similar, their sides are in proportion. So here if we take AB, the side AB, its corresponding side is D. So if we take the ratio of AB divided by D, that must be equal to ratio of, or another ratio of, corresponding sides. Now for the second ratio, in the denominator or as a first term, EF is there. So EF means the second and the third vertex. So its corresponding side is BC. So that should be in the numerator. As we have taken here AB, that is the side of triangle ABC. So in the another ratio also, in the numerator we should take the corresponding side of triangle ABC. That is BC divided by EF, because BC is the corresponding side of EF. So instead of the blank space, we should have BC, and that is the third alternative, that is option C is the correct alternative. So we must understand the two properties of similar triangles. So if two triangles are similar, then their corresponding sides must be in proportion. Proportion in the sense, if we take the ratio of those two corresponding, those three pairs of corresponding sides, that must be equal. That means for this triangle itself, suppose if we have AB, its corresponding side is DE. So this is the first ratio, that must be equal to, the second ratio is BC divided by EF, and another ratio is, if we consider A and C, that is side AC, its corresponding side is DF. So if these three ratios are equal, that means sides are in proportion. And there is another property for angles of similar triangles, and angles are not in proportion, they must be equal. So these are the two properties for corresponding sides and corresponding angles of similar triangles. That is, if two triangles are similar, sides are in proportion and corresponding angles are equal or congruent. So this is the basic concept we must know to have the answer of such a question. Okay, let's have the next question. So this is the question based on the diagram given. So in the diagram, triangle ABC is given, and it is given that in figure BD is 8. So this is BD given to be 8. BC is 12. So we have BC here. Its length is 12. And B dash D dash C, that means B, D and C are collinear points. And from this we have to find this ratio, that is ratio of area of triangle ABD and area of triangle ADC. So to have the ratio of these two triangles, we know that if we consider triangle ABD, this one, this is the triangle ABD, and we have to find its ratio with triangle ADC. So for both these two triangles, if we draw here a perpendicular line from point A to side BC, so that would be the height for both of these two triangles. So for both of these two triangles, height is equal or height is same. So if such a condition is there, then we know that we have one property, that if two triangles are having the same height or equal height, then the ratio of their areas must be equal to the ratio of corresponding bases. So if we consider ratio of area of triangle ABD divided by area of triangle ADC, for triangle ABD, BD is the base, so that must be equal to BD divided by area of triangle ADC, for triangle ADC, DC is the base because AE is the height which is drawn on the base. That's why DC is the base. So that should be in the denominator. So if we just substitute these values, we get the answer. Now BD is given to be 8. So that is equal to 8 divided by. Now DC is not given. So here the length DC is there. But we can find DC as BC is given to be 12 and BD is given to be 8. So if we subtract 8 from 12, that is BD from BC, we get DC. So 12 minus 8, that should be 4 here. So the length of DC is 4. Now if we simplify this one, 4 ones are and 4 twos are 2 divided by 1. And 2 divided by 1 is nothing but 2 is to 1. So this is the answer of this question, that is the ratio of areas of these two triangles is 2 is to 1, and this is given at alternative B. So second alternative is the correct alternative. So this is how we can solve examples based on this property. Now for this question, height is same. Now there may be another question in which the base must be common, and for that triangle we have to find this ratio. There is a ratio of areas of two triangles. So suppose there is one diagram like this. Okay, so let's consider this as triangle P, Q, R and S. Now if we consider these two triangles, triangle PQR and triangle QRS, if PQ is perpendicular to QR and SR is perpendicular to QR, then these two are heights, and here both the heights are drawn on the same base, that is QR. So QR is the base for both of these two triangles. So for these two triangles, base is same. So if such a condition is there, then ratio of areas of these two triangles must be dependent on the ratio of corresponding heights, that means PQ divided by RS. So these are the two properties on which question may be asked. So for this question, the height is same, so we have taken the ratio of the corresponding bases. Okay, now let's have the next question. So this question is again based on the diagram given, triangle PQR. In the figure, ray QS is the bisector of angle PQR. So QS is the angle bisector of angle PQR, that's given. And here it is given that PQ is equal to QR. So if PQ is 4 cm, QR is also 4. That's given. And from this we have to find PS divided by SR. And the four options are 1 is to 1 or 1 is to 2 or 2 is to 1, or the last option is cannot be determined. Now here to solve this we have to use the angle bisector property. So in a triangle, if the angle bisector of any one angle is given, then sides of that angle, that is here QS is the bisector of angle PQR. So the sides of angle PQR are PQ and QR. So if we take the ratio PQ divided by QR, by angle bisector property, that must be equal to the two parts of opposite side of that angle into which the ray QS divides that side, that is PS divided by SR. And we should note here that as we have taken here PQ in the numerator, we have to take to the other side PS divided by SR and not to take SR divided by PS. So if we take SR divided by PS, that is not the correct application of this angle bisector property. Okay, so this is PQ divided by QR is equal to PS divided by SR. This is by angle bisector property. Now here it is given that PQ is equal to QR. So on the left hand side, PQ and QR will get cancelled as they are equal. So we get 1 divided by 1 is equal to PS divided by SR. And 1 divided by 1 is nothing but 1 is to 1 is equal to PS is to SR. That is PS divided by SR is equal to 1 is to 1. So this is the alternative. First alternative is there, 1 is to 1. So our answer is 1 is to 1. Okay. So this is the question based on angle bisector property. Now let's have the next question. Now what problem is there? A vertical pole 40 meter long casts a shadow 20 meter long on the ground. At the same time, dot dot tower cast a shadow 50 meter long on the ground. So what would be the height of that tower? That is the question. Options are 100 meter, 50 meter, 25 meter or 150 meter. Now to solve this question, we have to draw one diagram. It is given that the vertical pole. So we should draw here a vertical pole. So let us consider AB as the vertical pole, and its length or height is 40 meter. So it's 40 meter, and it casts a shadow of 20 meter long on the ground. So let us consider BC as its shadow, and its length is 20 meter. At the same time, it is given that there is one tower also. So let us have another diagram, or let us have a segment PQ which denotes the tower and which casts a shadow of 50 meter. So let us consider QR is the shadow of that tower, which is 50 meter. And for this question, it is asked that what would be the height of that tower. That means we have to find PQ. So let us consider PQ as X. Now to solve this question, we have to join A and C so as to get the triangle complete. Also, we have to join PR. Now as these are the vertical pole and the tower, they must be perpendicular, and these are the two triangles we get at the same time. That means they must be similar. So we have got here two triangles which are similar. So if two triangles are similar, then we can use its property. That is, here triangle ABC is similar to triangle PQR. And mind that here we have to take the correspondence exactly like this. Triangle ABC similar to triangle PQR and not PRQ or QRP. We should take exact correspondence, then only we can get the result. So these two triangles are similar. As we have studied earlier, if two triangles are similar, their corresponding sides are in proportion. So we need not to take all the three pairs of corresponding sides. Only we are going to take two pairs of corresponding sides which are asked in the question. So here AB is given, so we'll take firstly AB. So its corresponding side is PQ. So AB divided by PQ. So this ratio must be equal to, we should take now BC as BC is given here. BC divided by its corresponding side is QR. In the denominator we should have QR. So AB is given to be 40 divided by PQ. We have to find, we have supposed to be X, that is equal to BC is again given to be 20 divided by QR is given to be 50. So we get this equation. If we solve this, we'll get the answer. So 40, if we have to, here we have to cross multiply. 40 into 50 is equal to 20 into X. We have to find X, so we should transfer 20 to the left hand side so as to get 40 divided by 50. Sorry, 40 into 50 divided by 20 is equal to X. So if we divide by 20, 20 to the 40. So 50 into 2, that is 100 is equal to X. That means the length of or the height of that tower must be 100 meters. So this is given at alternative A. So alternative A is the correct alternative. Okay, so this is how we can solve such questions. Now this is the question may be asked for multiple choice questions or for 1 mark question in question number 1B, or it may be asked for 2 mark question also. So if we have our basics clear, we can solve it for any of the question number, that is question number 1, 2, any of the question it is asked, we can find its answer. Okay, let me check out on network firstly. Okay, good. So this is the next question. Sides of two similar triangles are in the ratio 3:5. Areas of these two triangles are in the ratio ... 25:9, 3:5, 9:25 or 5:3. That is the question. So here also the sides of two triangles are given in the ratio 3:5. So let us suppose those sides S1 is to S2 and it is given to be 3:5, and we have to find the ratio of their areas. So let us consider A1 and A2 with the areas of those two triangles. So that must be equal to, and we have to use here one property of similar triangles, that if two triangles are similar, then the ratio of their areas must be equal to the square of ratios of their corresponding sides. So the ratio of corresponding sides is given to be 3:5, that means 3 divided by 5. And as these two triangles are similar, we have to make it square. So 3 divided by 5 bracket square. Most of the time we take 3 divided by 5 as it is, but it is not the case. If two triangles are similar, then the ratio of their areas must be equal to the ratio of squares of their corresponding sides. So 3 square is 9 divided by 5 square is 25. So 9 divided by 25, that means 9:25 is the correct answer. That means the ratio of these two areas is 9:25, which is given at option C. So option C is the correct alternative. Okay, let's have the next question. The areas of two similar triangles are 36 centimeters square and 121 centimeters square. The ratio of their corresponding sides are, so these are the options given: 36 is to 121, or 121 is to 36, 6 is to 11, or 11 is to 6. So again the same property is used, we have to use here, because the areas are given this time. So let us consider the area of first triangle, that is 36 centimeters square, and area of the second triangle is 121 centimeter square, and let their sides be S1 and S2. As these two triangles are similar, if we take the ratio of areas of these two triangles, that is A1 divided by A2, that must be equal to S1 square divided by S2 square, because if two triangles are similar, then the ratio of their areas must be equal to squares of their corresponding sides, ratio of squares of their corresponding sides. So A1 is 36, that's given, and A2 is 121, that is equal to S1 square divided by S2 square. Now we have to find the ratio of their corresponding sides and not square, so we should take square roots on with both the sides. So square root of 36 is 6 divided by square root of 121 is 11, that is equal to, on the right hand side also we have to take a square root, that is S1, square root of S1 square is S1 divided by square root of S2 square is S2. So S1 divided by S2 is equal to 6 divided by 11, that is 6 is to 11. So this is the ratio of corresponding sides. Now here option D is there, 11 is to 6. So we should consider that as the ratio of as the areas of two triangles are given in the respect 36 and 121, we have to take the ratio 36 divided by 121. If here we take 121 divided by 36, then we can get the wrong answer. So that's why the correct answer is 6 is to 11, that is alternative C is the correct alternative. Okay, let's have the next question. Here again two triangles are given to be similar. Triangle ABC is similar to triangle DEF. Measure of angle A is 45 degree, measure of angle E is 87 degree. Then what should be the measure of angle C? Options are 45 degree, 87 degree, 48 degree, or cannot be determined. Now we have to find the measure of angle C. So just consider triangle ABC. For this triangle we have the measure of angle A, that is 45 degree. We are asked to find the measure of angle C. Now if we can find measure of angle B, then we can get the measure of angle C, as the measures of two angles of a triangle are given. From that we can find the third one by using the property that sum of measures of all the three angles of a triangle is 180 degree. So we have measure of one angle, just we have to find the measure of angle B. If we can find, we can get the answer, we can get the measure of angle C. Okay, now for that one, these two triangles are given to be similar. So if two triangles are similar, then their corresponding angles are congruent. So angle A is congruent to angle D, B is congruent to angle E, and C is congruent to angle F. But here angle F is also not given, but angle E is given. So measure of angle E is 87 degree and its corresponding angle, that is corresponding angle of E, is angle B. So they must be congruent. Measure of angle E is 87 degree. So measure of angle B is also 87 degree. Now for triangle ABC, we have the measures of 2 angles out of 3. Now we can find the measure of angle C. As if we add these 3 angles, angle A plus angle B plus angle C is equal to 180 degree. As the sum of measures of all the 3 angles of a triangle is 180 degree. So angle A is 45 degree. We replace here. Angle B 87 degree plus angle C, we have to find it, that is equal to 180 degree. So 45 plus 87, 132 degree plus angle C is equal to 180 degree. We have to find angle C, so just transfer 132 to the right hand side. It is 180 degree minus 132 degree. So 180 degree minus 132 degree, that's 48 degree. So measure of angle C is 48 degree, which is given at alternative C. So option C is the correct answer for this question. Okay, let's have the next question. In triangle ABC, AD is the bisector of angle BAC and B', B, D and C are collinear points. AB is equal to 8, BD is equal to 6, DC is equal to 3. Then the length of segment AC is dot 4 cm, 3 cm, 6 cm or 8 cm. Now to solve this question we should have a diagram. So let's draw a triangle. It is triangle A, B and C, and it is given that for this triangle AD is the bisector of angle BAC. So just draw angle bisector AD, which is the bisector of angle BAC. So these two angles must be congruent. Now for this triangle, AB is given to be 8, BD is given to be 6, DC is given to be 3, and from this we have to find AC. So let it be X. Now as angle bisector is given, we have to use the angle bisector property. So by angle bisector property for this triangle, the two sides of angle are AB and AC. So if we take the ratio AB divided by AC, that must be equal to, we should take BD divided by DC on the right hand side. So BD divided by DC. So AB is given to be 8 divided by AC, we have to find it, that is X, is equal to BD is 6 divided by DC is 3. Now if you cross multiply 8 into 3 is equal to 6 into X. We have to find X, so transfer 6 to the left hand side so as to get 8 into 3 divided by 6 is equal to X. Now if we simplify, 3 1s are and 3 2s are 6, again 2 1s are and 2 4s are 8. So 4 into 1, that's 4, is equal to X, that is X is equal to 4. So the length of segment AC is 4 cm. So this is given at alternative A. So first option is the correct answer for this one. So here also we have used the property of angle bisector. Okay. Let's have the next question. This is the question again based on this diagram given. In the figure it is given that angle AED, this one, angle AED is congruent to angle ABC. So these two angles are given to be congruent. And AD is given to be 3, DB is given to be 5, A is 4. What would be the length of AC? That is the question. We have to find the length of AC. Now here we cannot use any of the properties like basic proportionality theorem or angle bisector property, but as this is given, we can have the pair of these two triangles, that is triangle AED and triangle ABC. If we can show these two triangles are similar, then we can use the property of similar triangles, that is the corresponding sides of similar triangles are in proportion. So here the pair of one angle is already given, AED is given to be congruent to angle ABC. Only we need another pair of angles to have to use the A test of similarity, and that angle is angle A, that is angle DAE is congruent to angle BAC as it is a common angle. So by A test these two triangles are similar. Now as this is a multiple choice question, we have to just find the answer, not need to write it properly. So these two triangles are similar by A test, and as these two triangles are similar, the corresponding sides are in proportion. So here the first side is going to be AD, that is the first and the third vertex. So we get the side AD. Its corresponding side is AC, so that should be in the denominator. AD divided by AC. AD divided by AC, that must be equal to. Now we should have AE, that is first and the second vertex. So AE divided by its corresponding side is AB. Okay, this is AE divided by AB is equal to AD divided by AC. Now we have the length of segment AE. AD is given to be 3 divided by AC. We have to find AC. So let's write it down. AC is equal to AE. It is given to be 4 divided by AB is not given, but we can find AB as AB is the sum of two smaller segments AD plus DB. So 3 plus 5, that's 8. So the length of segment AB is 8. So that should be in the denominator. So 3 divided by length of segment AC, let it be okay. Let the length of segment AC be x. So now if we cross multiply, we get 3 into 8 is equal to 4 into x. Again, if we transfer 4 to the left hand side, 3 into 8 divided by 4, that should be in the denominator, that is equal to x. Now if we divide by 4, 4 to the 8, so 3 into 2, that's 6 is equal to x. So the length of segment AC is 6, which is given at option B. So option B is the correct alternative for this question. Next question. The areas of two similar triangles are 9 cm square and 16 cm square. Ratio of their corresponding heights is. The options are 9 is to 16, 3 is to 4, 4 is to 3, or 16 is to 9. Now here the corresponding heights are given. We have one property of ratio of areas of two similar triangles. So if two triangles are given to be similar, then the ratio of their areas must be equal to a square of ratio of the corresponding sides, that is S1 square divided by S2 square. Now we should consider that if this is the property is true for corresponding sides, it is also applicable for the corresponding heights also. So for these two triangles, suppose H1 and H2 are the heights of those two triangles, then the same is applicable for this one, that is ratio of areas of these two triangles is equal to ratio of squares of the corresponding heights also. So that should be equal to H1 square by H2 square. Now here areas are given 9 and 16. So if we replace here A1 by A2 by 9 divided by 16, that should be equal to H1 square divided by H2 square. We don't want the ratio of H1 square and H2 square. We want the ratio of H1 and H2. So we should take a square root on both the sides. So square root of 9 is 3 divided by square root of 16 is 4. That is equal to H1 divided by H2. So this is the ratio 3 divided by 4. That means 3 is to 4 and not 4 is to 3. So 3 is to 4 is our correct answer, which is given at alternative B. So B is the correct answer for this question. Let's have the next question. Which of the following is not the test of similarity? So that's obvious. We have three tests of similarities, that is AAA test, SAS test, and SSS test. So no such SAA test is there for similarity of two triangles. So the correct answer for this question is SAA test, because no such a test is there for a similarity of two triangles. So the answer of this question is alternative C, SAA test. Next question is, the corresponding medians of two similar triangles are in the ratio 4:7. Let their respective areas be A1 and A2. Then what should be A1 is to A2? So here we have to find again the ratio of areas of those two triangles. That is, we have to find A1 divided by A2. And four alternatives are given to be 16:49 or 4:7 or 7:4 or 49:16. So here the medians are given. In the previous example, we have taken one question for the heights of those two similar triangles. So the same property again applicable for the medians of those two similar triangles. That is, if two triangles are similar, then the ratio of their areas must be equal to square of ratios of their corresponding medians also. So let us suppose M1 and M2 with the medians of that triangle, those two triangles. So the ratio of their areas must be equal to M1 square divided by M2 square. Now this time we are given the ratio of M1 divided by M2 because here the medians, corresponding medians of similar triangles are in the ratio 4:7 is given. So we can write here M1 divided by M2 bracket square. So M1 divided by M2, that is M1 is to M2, and that is 4 divided by 7 bracket square. So 4 square is 16 divided by 7 square is 49. So this is the ratio of areas of those two triangles, that is 16 divided by 49. That is nothing but 16 is to 49. So this is our answer, which is given at alternative A. So first option A is the correct answer for this one. And the next question is based on this diagram again. In figure, line AD is parallel to line BE is parallel to line CF. That means AD, BE and CF are three parallel lines, and as we can see, AC and DF are their transversal. So here the length of segment AB is given to be 8, BC is 4, DE is 6, and from that we have to find EF. Let it be X. So what would be the value of EF? That is the question. The four alternatives are 3, 12, 8 and 4. Now here we have to use the property of intercepts made by two transversals on three parallel lines. So here AD, BE and CF are the parallel lines, and AC and DF are their transversals. So the intercepts made by transversal AC are AB and BC. So if we take this ratio AB divided by BC, that must be equal to the intercepts made by three parallel lines on the second transversal, that is DE and EF. So that should be equal to DE divided by EF. So this is the property. Now we have the value of AB, that's 8, divided by BC is 4, is equal to DE is 6, and we have to find EF. Let it be X. So if you cross multiply 8 into X is equal to 4 into 6. We have to find X, so transfer 8 to the right hand side. 4 into 6 divided by 8, that should be in the denominator. So 4 ones are 4 twos are, again 2 ones are 2 threes are. 3 into 1, that's 3 divided by 1, that is nothing but 3, is equal to X. So the length of segment EF is 3, which is at alternative A. So option A is the correct answer for this question. Now let's have the next. Okay, so these are the all questions which we have solved based on the topic similarity, which are multiple choice questions. So if we have all these basic concepts clear, we can solve all the questions like this. Now these questions may be asked for 1 mark question or 2 mark questions. We should have our basics clear. So let's try to make our basics clear, and there is one link given in the description where all the topics, all the practice sets solved from various topics for class 10. So various videos are there, about 200 videos are there. Just check it out to get our concepts clear. So there is one playlist, link of the playlist like class 10th maths. So just check it out. So that's it for now. These are the questions we have solved for the topic similarity, multiple choice questions. Let's have another session tomorrow in the morning. We'll have another topic for that session. So that's it for now. Let's end this. Thanks for watching.